There it says unmute. Hello, here we go. We should go to
Does the banner, the welcome banner, disappear?
Yes.
Thank you. Hello, Ellen.
Hi, everyone. I wanted to welcome you to our virtual DMF talk in partnership with the Lagoon Committee. As Del Mar's oldest 501c3 nonprofit, the Del Mar Foundation sponsors programs, makes grants, and manages over $5 million in endowment funds to benefit the community and the San Diego Lagoon. The community endowment provides long-term funding stability for our community needs. The DMF Talks is our unique version of TED Talks. We draw our speakers from the exceptional local-based creative, intellectual, and scientific community members. For the past 8 years, DMF Talks is aimed to entertain, inspire, and inform the Del Mar community through a series of free presentations. Tonight's virtual presentation will be a first for us, and we ask for your help. Please keep your microphones muted to prevent the background noise. You might also consider turning off your video to ensure that we have adequate bandwidth for this presentation. I promise you'll still be able to see the presentation if you turn off your video. To best enjoy the talk, we advise you to switch to speaker view rather than the gallery view. You can find that in the right-hand corner of most computers. We ask that you stay muted throughout the talk and direct all questions and comments through the chat feature. This evening, we'll have a moderator and a speaker, followed by a question and answer session. The moderator will be monitoring the chat box. We thank you for your cooperation. At this time, I'd like to introduce our moderator, Ellen Breen, the chair of Del Mar's San Diego Lagoon Committee. She received her Ph.D. in biochemistry from the University of Vermont and had postdoctoral training in cell biology at the University of Massachusetts Medical Center. She's a member of UCSD's Department of Medicine, studying various molecular biology and physiology mechanisms that regulate how we transport and use oxygen during exercise or with chronic lung diseases. Dr. Breen.
All right, thank you, Sandra. Can everybody hear me? It's my pleasure tonight to introduce Dr. Richard Carson to present some of his work for us tonight. Dr. Carson is a distinguished professor of economics at UCSD. He received his PhD from UC Berkeley before joining the faculty at UCSD in 1985. He's a past president of the Association of Environmental and Resource Economists, and he was elected a fellow in the American Association for the Advancement of Science for his work on climate change and environmental valuation. Earlier, he served as the research director for the International Environmental Policy of UCSD's Global Conflict Cooperation. He's worked on several environmental projects over the years. Some of these include arsenic contamination in Bangladesh, forecasting CO2 emissions in China, conducting benefit assessments for the US Clean Water Act and its British equivalent. He also served as the principal investigator for the economic component of the government's damage assessment for the Exxon Valdez and the BP Deepwater Horizon spills. I'd also like to note that once upon a time, he actually lived in Del Mar, and he contributed his expertise in the effort to secure the restoration project for our San Diego Lagoon. So it's my very pleasure to have him share some of his work with us tonight. So thank you, Richard, for spending some time with us tonight.
Okay. Anyway, this is going to be hopefully entertaining. This is the first time I've done something like this via Zoom. So I chat all day on Zoom, but we'll see how this works. Let me share my screen and I'm actually not going to talk exactly about what the Del Mar Lagoon, the San Diego Lagoon is worth. What I have been working on is a related topic, and that is the role of coastal wetlands in reducing property values during tropical cyclones. And this is joint work with a recent graduate student of mine, Lynn's son, who's now at Amazon, doing spatial modeling, helping all of your packages get to you. And anyway, this paper recently came out about a month and a half ago in the Proceedings of the National Academy of Sciences. Okay, so let me give sort of a brief overview here. The US gets hit all the time by tropical cyclones. In the US, I should say, in the sort of northern Pacific as well as the Atlantic, these are called hurricanes. In a large part of the Pacific, they're either called cyclones or typhoons. And the West Coast occasionally gets hit by these. It fairly often, a lot of the flooding actually occurs at the tail end of these events. San Diego got hit once with a hurricane back in, I want to say 1858. And the largest hurricane ever observed was south of Baja, which had winds of about 200 miles an hour, and that wasn't that long ago. Okay, so what we're going to use in doing this is the fact that there are lots of these tropical cyclones, and they're going to hit over different time periods, over 2,500 different sort of county years. And what you can think of is that property damage occurs from these events, and it occurs because of storm surge, wind and flooding. And there are a couple things that can reduce these. One is wetlands, another is building codes, infrastructure, and the disaster response. So what we're going to do in this is I'm going to show you how we get at what an economist calls the marginal value of protecting an extra square kilometer of wetlands. And so what you can think of there is we're going to get the value of sort of adding another hectare, kilometer, acre of wetlands. And if you want to think a square kilometer of wetlands is about 247 acres. Okay, and we're going to use what's known as an ecosystem services approach. This is, at some level, is sort of an old approach. Agricultural economists forever have looked at, say, how production of a crop like corn is influenced by rainfall. And they then look at how that rainfall gets capitalized into land values. And what we're going to do here is we're going to look at how wetlands influence property damage in these big storms. So we, of course, are not the first to do this. Mangrove forests, which are a type of wetlands, it's a really bad thing happens in places like Thailand and Vietnam. Companies sort of move in and cut down the mangrove forest, and the shrimp farms last for 7 to 12 years, and then they move on. And once they're destroyed, the villages are much more susceptible to being hit by these cyclones. Louisiana, of course, is the home of most wetlands in the US. And depending on your favorite poison, you can clearly show that, for instance, Hurricane Katrina would not have done the harm to New Orleans that it did if the wetlands that were once in front of New Orleans were still there. So anyway, an earlier study was done by Bob Costanza that some level nobody really believed, because the government really wasn't collecting the data on where the wetlands were, and the only storms that they had property damage for were big storms that did lots of damage. So let me just give you some notion of the tropical cyclone classification. This is sort of the sustained wind. So it goes tropical storm, hurricane category 1, 2, 3, 4, and 5. When these storms start out, they become cyclones when they develop sort of the prototypical sort of swirling eye. And that starts at what's called 34 knots. The knots are sort of an ancient British navigational term where they actually let out a rope with knots to measure how fast they were going. So anyway, it corresponds reasonably well with miles, but not completely. So here's the raw data that we have to work with. These are all these storms that hit the US over this 21-year period. So we've got, they're more blue lines because they're more tropical storms. They're smaller, sort of category 1 and 2 hurricanes. And then the red lines are these bigger hurricanes. And the one thing to note is that as you go over the US, the wind does die. So this is sort of their maximum speed. But it's all this randomness that's going to allow us to figure out how much protective value the wetlands are playing. Okay, this is just a simple bar chart of wind intensities on the horizontal axis and sort of the frequency at which they occur. And the key thing to note here is that these smaller storms are clearly the more dominant sort of factor. And even if a storm comes across as say a category 4 hurricane, by the time it hits most counties, it's going to fall off considerably. So this is just a chart that shows you that the really big damage is, of course, being done by the really big storms: Katrina, Sandy, Wilma, Ivan, Francis, Rita, storms that you probably are familiar with. But anyway, starting in 1996, the government started collecting data on the property damage associated with each of these tropical cyclones. Okay, I promise not to give a talk with hardly any math, but we'll have one slide, 2 slides. So what you can always think of with property damage here is that there's really 2 parts. There's the probability that there's any damage at all. And it turns out most big storms go through counties and actually do no damage. And then conditional on there being damage, how large is that damage? And so anyway, underlying the paper, if you want to read it sort of online, you can see all the math. This project took us about 2.5 years to do. And so this is one indication of where all that time goes. So we had to figure out what areas are hit by each tropical cyclone in each county, the wind speed that hit that area, the angle at which it was hit, the area at risk from storm surge, which involves a sort of physical typological modeling, including elevation. We then have to locate all the wetlands, and this quantity is going to vary over time, and this sort of variability in the amount of wetlands over time is again going to be crucial to letting us figure this out. So as an economist, in contrast to some of my good friends in the sort of biological sciences, we have to look for natural sources of random variation for a lot of things we're going to do. And so it's going to be the variation of where these storms come that are going to allow us to do this. So anyway, we locate all the wetlands, the quantity varies over time and space, and then we have different types of wetlands: freshwater versus saltwater, and forested versus non-forested. And I'll show you pictures of those in a minute. And then we have to do a lot of detailed mapping of all the houses. So the Census Bureau reports how much all the houses are worth at a sort of a level just slightly above street level. Okay, so we've got lots of data sources. The U.S. National Oceanic and Atmospheric Administration is our friend. They provide the wetland coverage. The U.S. Geological Survey provides a lot of the topological features that we use. NOAA again provides the hurricane track data. So these are all these hurricane paths that you see over and over again on TV. Then they started recording the property damage, as I said, in '66. And then we use lots of census data to figure out where the houses and the people are. Okay, but maybe a picture here is better than all those words. This is Hurricane Katrina. Hurricane Katrina actually came across Florida, somewhat above Fort Lauderdale, where it came almost east to west. It went over the Gulf of Mexico, where it picked up speed. And one of the things that climate change is doing is there's more heat in the ocean. So it's hard to show that climate change will cause more hurricanes, but the ones that do form will pick up both more heat and rain. And Hurricane Harvey in Houston is a really good example of how these hurricanes are going to pick up a lot more rain, and so there'll be a lot more flooding. So all the little brown dots on the map and the sort of blow up of the map around New Orleans, those are the wetlands that we've mapped. So the pink area is the area that we estimate, given the magnitude of the winds and the sea, are potentially subject to flooding. And then one of the things we use is that every storm generates this sort of wind profile where the wind is more intense in the center near the eye and sort of fades out. And so every one of these things has a shape, and every one of these things every hurricane, tropical cyclone has an angle of attack. And so you can see what's going to happen here is that Katrina is going to go east of New Orleans. It's actually going to hit the Mississippi coast right across from the Louisiana border. But anyway, it's going sort of almost due north at that time. And then you can see its eventual track is going to veer off a little bit to the right. Okay, so what influences whether or not there's any damage? And they said most of the time, which in this case is exactly 65%, there is no damage. And one of the things that happens is the more wetlands you have, the more likely there will be no damage when one of these tropical cyclones hit. So we show the probability that there is damage goes up with respect to the wind speed, how big we impact the storm flooding area. And an interesting feature, being hit on a storm's right side. And I'll talk about that more in a minute because we provide the first estimates of what happens there. So interestingly, property value is not a significant predictor about whether you have any damage. And the random component here is coming from, I said, the very specific storm track, the fact that within any sort of tropical cyclone / hurricane, you can get gusts of wind. They do a fair amount of damage, and rainfall and when the hurricane hits the coast makes a difference. So of the 207 counties in the US had damage from one of these tropical cyclones at least once. And so that's most of the counties that were hit. Okay, this is the other sort of math. So we estimate the statistical models. And so what we're going to do is we're simply going in a regression model. We're going to say the damages, in this case, the log of the property damage is a function of wetlands, wind, storm area, property risk, and we're going to control for what a statistician would call a lot of fixed effects. We have state fixed effects and we have time period fixed effects. So here's the key result. If your amount of wetlands goes down by 1%, what's going to happen is that your damages are going to go up by 0.6%. That's a big effect, and we'll see that in a minute. We also managed to quantify several things that have eluded people over the years. Technically, the energy in the wind goes up at the cube of wind speed. What we show here is that a 1% increase in the wind speed, say on the edge of going from a category 2 to a category 3 hurricane, is going to increase the amount of damage by a little over 5%. Okay, we then get a very interesting result. What we show is that wetlands have much greater, what we call relative protective ability for the smaller storms, the tropical storms, the category 1 and category 2 hurricanes. And however, they have a larger absolute effect for these really big hurricanes, and that's because that's generating a lot of the property damage. And so a way to sort of think of this, and you'll see some pictures of it in a minute, is that for a really big hurricane, the wetlands are going to get overwhelmed. And so they provide sort of the initial sort of response. Okay, so this is a Caribbean island called Barbuda that got hit by Hurricane Irma. And we'll see some other pictures of Hurricane Irma. This was a category 5 hurricane when it hit Barbuda. Basically, there's nothing left in a category 5 hurricane without really hardened structures. And indeed, on the island of Barbuda, I think it destroyed 99% of the structures on the island. Okay. This, however, is the more typical hurricane to hit the US. This is Hurricane Irma when it came across and hit Fort Myers, Florida. This is somewhere around a low 3, high 2 hurricane. When it hit Marcos Island off Fort Myers, it was a 4. And so these islands absorb the brunt of this. But what you can see here is we've gone from basically wind damage to water damage. And that's where the wetlands are really going to come in and play a role. Okay, let me talk just about for a moment. So in the northern hemisphere, hurricanes turn counterclockwise. And what that means is that because they turn counterclockwise, they're pulling in water when someplace gets hit on the right side, and it's pushing out water when it gets hit on the left side. And so we show that we have the first estimates here of being hit on the right side increases property damage by about 140%. So that's a fairly large effect. And for the most part, we actually do quite good at predicting damages. So we've got the natural log of damages observed on the horizontal axis and the predicted damages on the vertical axis. And you know, it's not a perfect straight line, but it's pretty good for this sort of thing. Okay, the next thing that we're going to turn to is looking at different types of wetlands. There's been a really big debate amongst ecologists between the differences between freshwater and saltwater wetlands, and we find no difference there. And part of the reason for that is that there are many fewer saltwater wetlands. They're right on the coast. But a lot of the property that's at risk are up river and stream systems. And so the wetlands there actually provide lots of protection. So on average, there's no difference. We also find no difference between forested and non-forested wetlands unless we know a lot more about the storm. And this is consistent with contradictory claims in the science literature. And there's a reason for that. This is what a forested wetlands look like. And it turns out these forested wetlands are much better at knocking down the wind. This is what a non-forested wetlands looks like. And it turns out the non-forested wetlands are much better at absorbing water. And on average, those two effects just about counterbalance. The question that we then always get asked are, well, can't we just build stronger houses in some sense? And what we show is that these building codes, when we take account of the building codes, you get large differences. Interestingly, Florida and South Carolina have very tough building codes. Mississippi, Alabama, and Texas essentially have no building codes. But what we do show is that even in states with very strong building codes, the wetlands still play a very large role in reducing property values. Damage to property. Okay, we do lots of robustness checks. We drop lots of things in and out. One might be worried that Katrina and Sandy are driving the results. We drop those out. That doesn't do much. We show that there's not a time trend in these, and that if anything, our estimates are probably a bit underestimated. So how do we get the value of storm protective services? What we effectively do is we look at how expected damages change as you change the wind. And so mathematically, this is just taking sort of a derivative. We have to normalize the units. As economists, the one thing that we don't do is we don't predict how much wind there's going to be, but Colorado State University has a large project that forecasts the probability that all the counties on the Gulf of Mexico and the Atlantic coast get hit by different wind and how often they get hit. So we're going to use their results. And it's important to note that this doesn't take account of future climate change. So if we're going to have more category 3, 4, and 5 hurricanes, again, these estimates are probably on the small side. So we aggregate over 30 years because the wetlands provide these ecosystem services over time. We also have estimates for 100 years, which is common for water projects. We discount those by 2.8%, which is what the U.S. Office of Management and Budget says to do. And voila, we get a mean estimate of $36 million per kilometer, and a median estimate of 2 million. And just to put the 36 million in perspective, that's about $250,000 per acre. So what we've done is that we provide estimates for all the counties on the Gulf and Atlantic sides, and the color coding here suggests or contains our estimate of what the value of the wetlands are. And the value of the wetlands differs considerably. And the reason for that is, for instance, there's some parts of southwestern Louisiana where an extra acre or square kilometer of wetlands is worth, we should say, not very much. And the reason for that is that there are a huge number of wetlands there and there are almost no people. Likewise, if you look at, say, the coast of Maine, the wetlands in Maine are not worth very much, and that's because the wind from these tropical cyclones, by the time it gets to Maine, is very low. So on the other hand, we could look around Boston or New York City or Washington, D.C. We could look around Houston, and there we find that a square kilometer of wetlands can often be worth, over 30 years, well in excess of $200 million. We get some interesting cases that bothered us for a long time. If you look at Florida, and then you look at where Miami is, it turns out that the wetlands there aren't worth very much in terms of preventing property value, preventing damage to property value. And that's because the wetlands in Miami are the Everglades, and they're on the wrong side of Miami to provide protection. So Miami, of course, drained all the wetlands on the side that would prevent protection. And so in Florida, you get the big values for the wetlands in the Tampa, St. Petersburg area, and as you go north, sort of past Miami. Okay, so now let me turn to the storm track of Hurricane Irma. So as we already saw, Hurricane Irma was a Category 5 when it went over this poor Caribbean island of Barbuda. And what it did was it lost speed when it hit that island, and then of course, the warm water, it gained more heat energy, and it picked up speed. And so what it's going to do is it's going to wobble back and forth, and it's finally going to decide that it's going to go right up the Atlantic coast side of Florida. And you can see it's going to come ashore. I showed you the picture. The place that it came ashore is technically called Marcos Island, which is south of Fort Myers. And the different shades of the blue here, the darker the blue, the more intense wind. And you can see the the pinkish brown area is the area that we generate that, given the wind speeds, are subject to flooding, where the wetlands are going to make a difference. And Hurricane Irma happened right after we closed off the data from our study, and the official estimate of the damage for Hurricane Irma is not quite out yet. But what we estimate is that Florida, which has lost 2.8% of its wetlands since 1996, and there were 19 coastal counties impacted. So our model estimates that Irma did about $400 million more damage than if Florida hadn't lost those wetlands. And the important thing to note there is that under the US government's no net wetland policy, Florida shouldn't have lost any of these wetlands. And this is, depending on where the final damage estimate comes in, this will be somewhere on the order of 5 to 10% of the damage estimate for Irma. So that's a pretty big hit from just slow sort of loss of wetlands over a 20-year time period. One of the most important things is that there are lots of other functions of wetlands that we have not valued. So the wetlands are very important for fisheries and wildlife. They filter industrial, residential, and agricultural runoff. Wetlands provide a multitude of recreational opportunities, and they also sequester carbon. So in some sense, we have multiple billions of dollars of wetland benefits every year just on the Gulf of Mexico and the Atlantic coast. And there are two issues I'm going to sort of end here on. One is an open question, and that is, if you restore wetlands, how long does it take them to provide different levels of ecosystem services? Early efforts at restoring these wetlands, and I no doubt the folks involved in the San Diego Lagoon have found this out, it's very hard to effectively restore wetlands after you lose them. The other interesting issue is that there's been a big national fight over what water bodies are covered by the US Clean Water Act. And so I did the benefit assessment for the US Clean Water Act when it got renewed by Congress some time ago. And what the Trump administration did was decide that none of the wetland valuation studies that had been done were quote unquote reliable. And hence they then assigned zero economic value to wetlands. And on the basis of that, decided that a large fraction of those smaller water bodies in the US are not covered by the US Clean Water Act. One of the things that we hope to do with this study was to provide reliable estimates, at least of one of the sort of major components of the valuation of wetlands. We clearly don't have all of it, but our value for wetlands is actually large enough to overturn the benefit cost analysis that was done for the sort of gutting of the US Clean Water Act recently. Okay, and I think that is it. I am happy to take questions.
Okay, thank you. That was very interesting. I want to just let everybody know that they can type their questions into the chat box. I have a lot of questions, but I want to hear yours too. So lots to think about, lots more to do too, huh, Richard?
Yes.
So if you think about it, you know, the tropical storms, the gusts versus the flooding and the smaller storms. So the smaller storms would be more things like we would see on the West Coast. Would you say?
So most of our flooding tends to happen due to two events. We get hit by the tail end of lots of tropical typhoons and cyclones, depending on where they come. So the big storm track in the Pacific runs from Mexico, say Puerto Vallarta, to Hawaii. And occasionally these big storms creep up Baja, but the water is too cold to sustain them, although that is changing. So anyway, hurricanes, when they lose energy, they sort of start breaking up. But a lot of the flooding comes from the tail end of these events. The other way that we get flooding are events called atmospheric rivers, which if you see them from satellites actually look like sort of like hurricanes, but they're not twirling in quite the same way. These are these big sort of rain events, and they come over, and it turns out they have both a big influence on flooding, but they also have a big influence on drying. And so they're connected to wildfires. And they're, anyway, the Scripps Institution of Oceanography is sort of the #1 place that's studying these atmospheric rivers.
So I just got a question from Dwight. It's sort of similar. He asked, what are the benefits to the West Coast areas that don't get hurricanes?
Yes, well, as I said earlier, these wetlands are tremendously good at protecting against flooding from smaller storms. And we do get hit by lots of smaller storms. And the one thing we show is that these really big hurricanes are doing so much damage that in an absolute sense, if you were to knock, say, 5 or 10% off the damage that one of those are doing, it's huge. But if you look at these smaller storms, the wetlands, in a lot of cases, the wetlands are just absorbing the entire brunt of the storm. And so one of the reasons we split this model into the probability that you have any damage versus how much damage you have if there's a big storm is that the wetlands play a big role in this first phase. So that if you get hit by sort of moderate winds and you've got lots of wetlands, then you typically don't get any you don't get any major property damage.
Yeah. Okay, cool. I got another question from Janelle. The component of the right side of the storm causes most property damage. Is this only valid for storms that are hitting land from the south, like Harvey, because the storms rotate counterclockwise?
Yeah, they always rotate counterclockwise. So you can always get the angle of attack of these storms, and then you're looking at the right side. So it's the main thing is that they're just, as they're twirling, because they're twirling counterclockwise, as they approach, they're just pushing the water in. So you can imagine that you've got this big wind and it's blowing the water in. And so all it has to do is turn, and then it's going to push the water out. And it's the water that does most of the damage. And that's why these people in Florida and Louisiana and Texas, they often think they have homeowners insurance, and there's typically a big debate over whether it's wind damage or water damage, because water damage is often not insured, and the insurers often like to tell people that their houses are going to be protected from wind. Yeah. And it's typically not the wind that does the damage.
Yeah, that's sort of sneaky. I don't like that one.
there are lots of people who have insurance policies who find out that the water damage is, even though it was blown in by the wind.
Yeah. Okay, I got another question from Dwight. Do you have any data on the cost of wetland acquisition and restoration versus the increase in damage from the loss of wetlands? Can the case be made for restoration and preservation pays for itself?
Let me distinguish between preservation and restoration. So our view is that preservation almost always pays for itself.
Mm-hmm.
The problem with restoration is that you just don't know how successful you're going to be at restoring the functions. And so different states, interestingly, in the early days where you had a real estate developer and they wanted to build on the wetlands, so this no net loss policy said, okay, I'll build where I want to, and then I'll restore an acre of wetlands somewhere nearby. And those projects in general were fairly unsuccessful. And so different states initially started saying, okay, if you destroy 1 acre of wetlands, you have to restore 2. And the 2 went to 5, and the 5 went to 10. And in some states, it's as high as 20 now.
Who comes up with those calculations?
Ecologists who, I mean, there are a bunch of folks who study wetland functions, and it just, you know, they don't, it takes a long, first off, there's a tendency to leave these things after you've met your requirement without fully restoring them. And it just turns out that it's hard. And so, but anyway, in terms of preserving, it would be a really, it certainly wouldn't be any standard residential development projects. I mean, in other words, you'd have to have something like building an airport runway into San Francisco Bay or something like that that might justify destroying them. But anyway, it'd be hard to get a good economist to make a case that you should be building on them almost anywhere.
Yeah, I agree. I got another question from Julie. She says, is the West Coast at risk for cyclones in the future with climate change?
I do a lot of work on climate change. I'm not, I don't forecast that. Dan Can and other folks at SIO do this sort of thing. I think what one will probably see over the next 20 years is that the intensity of what we get hit by will go up. I don't know. The waters would have to warm considerably before we have hurricanes come pretty high up the Baja Peninsula. I think that the temperature differential is just, I think, high enough that even a couple degrees of warming is not going to quite do that. But what it will do is all the tail. So San Diego is very interesting in that we actually get most of our rainfall as a function of the tail end of these tropical storms, or as these atmospheric river events. I mean, in general, like it doesn't rain in May and June.
Yeah, it's a crazy place.
And so what will happen is that these storms, they die out, and so they will come in further, and so they will be more intense. And so I don't think we're in much risk of being, hit by a Category 3 hurricane, but if you said some of these storms are going to be tropical, low-level tropical cyclones when they come across and hit California, that could easily be the case.
Yeah. What about, like sort of man interventions like sand replenishment or seawalls or things that block the dredging, that block the opening of the water coming into the wetlands? Is that a big factor in your model?
One of the reviewers on the paper insisted that we do a lot of work to take account of all the hardscape along the Gulf and Atlantic coast. And we were able to show that even taking account of that, all our results were still valid. There is a substantive problem with doing the sort of analysis that we did, in that the only reason that we were able to do this is that NOAA has kept track of all the wetlands. And nobody has kept track of all the hardscape along the US coast on the Atlantic, the Pacific, or the Gulf. And so all we were able to do is find particular years when somebody had put together data sets for completely different purposes. But I do know more about beach replenishment. That's not a really good substitute for wetlands. It may be a very good substitute for beach recreation, but it's not, they don't, anyway, a beach is not going to provide anywhere near the protective sort of services of wetlands. And the reason to think about that is, if you remember my forested and non-forested wetlands, in one case you're knocking down the wind and the beaches don't do anything there. And in the other case you're absorbing huge amounts of water and the beaches don't do a whole lot there either.
Yeah. But like, I know that restoring wetlands isn't the best or the easiest to do, but if you like with this big W19 project where they're going to increase the area of the wetlands pretty substantially,
right.
that should, is there like a you know, is doubling the wetlands good, or just increasing it a little bit? Is there a cutoff for how much is good or bad?
Yeah, I mean, so economists naturally think of this sort of sweet spot. One of the reasons that Hurricane Sandy did so much damage, including, you know, flooding the subways in lower Manhattan, is they desperately need more wetlands. So if you were to pick a place where it's worth investing a huge amount of money to restore wetlands, there are some big US cities that yeah, I mean, a little bit more wetland would make a lot of difference. Now, there are a bunch of places that, you know, you might not see much difference, but so, you know, high population concentrations and low wetlands coupled with storms is bad news.
Yeah.
And the surprising thing when you do this is that it turns out the largest single place that the wetlands are the most valuable is part of Boston.
Oh.
And so Boston is actually subject to heavy flooding if a storm approaches at the wrong angle. Yeah, so you can pick out the places where you could justify enormous sort of construction projects in terms of restoring and building wetlands. But anyway, they are the big, you know, they are the places that would sort of be on your list.
The big cities.
Virginia is one of those. It's much more at risk than, say, Washington D.C. itself.
Are you gonna model the carbon sequestration in the wetlands? Is that on your list of things?
I have I have a graduate student who just got her Ph.D. down at Scripps. I wasn't her primary advisor, but we were actually trying to look at the carbon sequestration of alternative water filtration projects. So wetlands are really good at some of the functions that sewage treatment plants are good at. And so anyway, we have been measuring CO2, what types of wetlands and how they're sort of managed influences carbon sequestration. But I can't say that this is, Lisa Levin was her primary advisor, and so Lisa's like way better at this than I am.
Oh, okay. That's cool. We're really interested in that. How much are you know around here? Yeah,
so the answer is that wetlands do sequester a lot of carbon. And so as an economist, you're always looking at, does managing wetlands in different ways and does adding and subtracting to them influence carbon sequestration? And one of the things that you see is that oftentimes wetlands are threatened They get dried out in various ways before they sort of lose their functions. And it's clear from other work that one of the things that goes first is their ability to sequester lots of carbon.
Oh, interesting. I didn't know that.
So they're sort of drawing out.
Yeah.
Yeah.
Okay, well, I can't wait to hear more about your research in the future. This is super interesting. I really enjoyed it. I think that Sandra wants to say a few words before we end.
Yeah. So,
is that okay, Sandra?
Anyway, we're all sitting here at home alone, so hopefully I was entertaining at least.
No, it was really good. Yeah, it was great. Yeah, totally enjoyed it. And thank you so much for doing it. It's such a strange way to give a talk. You know, I know it's difficult.
Thank you, Dr. Breen, and thank you, Dr. Carson, for such a great talk and for being our first virtual guinea pig, and so we much appreciate it. As an aside, I lived in Florida for 13 years on the East Coast, and so I lived through 9 hurricanes, and so I could really get what you were saying, especially when it came to the insurance companies. So the economics of that.
Yeah, I mean, what's fascinating about Katrina is one of the things that happened in Katrina is that the oil companies and other people who were sort of drilling fairly shallow wells, they cut these big channels to get their boats through, and that was one of the paths that the wind went through and hit Katrina. That's why almost all the estimates show that if that hadn't happened, then New Orleans wouldn't have been flooded. The only wrinkle on that is that there was sort of construction fraud involved in the levee.
Oh yeah,
the levee.
That was a disaster. In the making.
Which is unfortunately typical Louisiana politics. When they looked at the levee, sort of the sort of steel rods that should have been in the concrete weren't there.
Yeah, unfortunately that happens all along up and down the East Coast. Oh well.
Well, I wanted to thank you all again for joining us, and we will have the recording and the link up for this on the Del Mar Foundation's homepage tomorrow. So I hope everyone has a really great night. Thank you.
Okay.
Thank you. Thank you, Dr. Carson. Excellent. Thank you.